talked about graphing and parent functions. Yesterday we did symmetry. We had a math Excel assignment. I was looking at grades this morning. Most of you are done. A couple of you have just a couple questions left. So if you need help with that, come see me. Owen, I know you were gone, so there's video, or if you want to come in and advisory, I can catch up. So today we are going to start talking about transformations. We are going to kind of break this up. Today's focus is only on moving graphs left and right and up and down. So we will look at all those common functions, the parent functions that we did on the notes handout I printed for you on Monday, and we'll be looking at shifts for those. So in general, when we are talking about transformations, if you take a function and you add something on the end, that moves your graph up that amount. If I take my original function and I subtract on the end, that moves my graph down, however many I subtracted. If I change my x value, so I'm not just tacking a +3 on the end, I am changing something inside my parenthesis. I'm changing my x. If you add to your x value, it goes the opposite. It will move it to the left. It moves it in the negative direction. And if you subtract from the x, it will move it to the right. So in general, what I always stress when we're doing transformations, anything on the outside it changes y, and it does what it says. I think y-axis, that's up and down, so adding goes up, subtracting goes down. The inside value, it's changing your x, and it does the opposite of what it says. So inside changes the x, does the opposite. So adding actually moves us in the negative direction. Subtracting moves us in the positive direction. You have tools to kind of help you with this if you're struggling when we get into transformations. You have a graphing calculator available to you. You can check it that way. However, you want to make sure you're not relying on your graphing calculator too much. Because first of all, I do require some exact points and your calculator doesn't show you those exact points. Second of all, I might give you scenarios where I've already drawn a graph and I ask you to do a certain transformation, so you can't plug that in your calculator. So use the calculator to check, but don't try to make it do your problems for you, because I'm going to give you some situations where that strategy wouldn't work. Okay, so it's a resource to help us, but not how we're going to get to our problems. All right. When we graph with transformations, what I am going to ask is that you always do your parent function and the final graph. We will do our parent function, our original function, those common ones that we were graphing on Monday. We will always do those with a dashed line. And then our final graph we'll do with a solid line. If you mix those up, then you just have to label which is which on your graph. It's not that big of a deal. But if you just do solid and dashed, I will assume the solid is your final answer. So I have given you two functions here. X cubed, that's one that we have been graphing already. And we know a little bit. I know I didn't give you guys graph paper, so here, I'll delete my graph. We'll do it together. So, we're going to draw ourselves a grid. What does x cubed look like?
Chair. Yes. Oh, yes.
It's like our chair. So 0 cubed is 0. 1 cubed is 1. -1 cubed is -1. I've asked for a minimum of 3 exact points, so if you know your shape, then you could finish it from here. If you're not sure about the shape, all you have to do is plug in more points if you did 2. Two to the third is 8. -2 to the third is -8. So here's my parent function. I'm going to do that one dashed. That's my original. All right, so then what would this +4 do to my graph?
It's not in parentheses, so it goes up.
Right, it's not in parentheses. It's on, so it's on the outside. So outside is y, and it does what it says. So adding would take it up. So we take each of these points that we plotted and move them up 4. The shape of the graph doesn't change. Just where it goes. Is that one okay? Alright. So let's take the absolute value of x and the absolute value of x minus 2. So absolute value of x, that's my parent function. What does it look like? V, yep. Minimum of 3 points, so absolute value is 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. Is everybody okay with how I'm getting the points for my parent function? So then, when I have the absolute value of x minus 2, that 2 is on the outside. Outside is y, and it does what it says, so it will take my graph down 2. So move each of my points down 2. Could you give me domain and range of that if I ask? This final graph, what's the domain? Good, negative infinity, positive infinity. What would the range of the final graph be? Good. So I could ask you domain and range for any of these, and all I'm wanting is draw the graph and tell me from your graph what's your domain and range. All right, let's see if we can work backwards. I'm going to give you guys a second to look at this and see if you can figure it out on your own. I want to know if you can give me the equation that would match this graph. So think about what your parent function is and how it was moved. See if you can get an equation for me. Okay, so we know it's an absolute value. So you could say f of x equals, or y equals, or g of x equals, whatever. And how did this move my normal absolute value? So minus 2 on the end. All right. Okay, what did you put for this one?
F1.
Absolute value of x plus 1. Good. Alright. Let's do this one. Alright, so g of x is x squared. And I want to graph g of x minus 3 and g of x plus 2. So, parent function, what's x squared look like? Good. Minimum of 3 points, you can do more. 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4. We do our parent function dash. Alright, so when I say g of x minus 3, I'm asking you to graph x minus 3 squared. So outside is y, does what it says. Inside changes the x. This is inside, it's in my absolute value. Or not absolute value, in my square, in my parentheses. And it does the opposite of what we say. So subtracting 3, we'll move it right 3. Will take us in the positive direction. Alright, I'm just going to color code mine. So I take each of these points, right 3. Same shape, just got moved over. And then I asked for one more on here. G of x plus 2, so that would be x plus 2 squared. So if you add to your x, what does it do? Moves in the negative direction, so we're going to go left 2. So it's based off the original parent function, this dashed one. So we'll move each of those blue points to the left 2. So far, so good? I want you guys to write the equations for these two graphs. Absolute value. This one moved to the right 4. So left and right changes x. If you moved right, you had to subtract. So that's x minus 4. And what's this one going to be? Absolute value of x plus 2. Are those okay? So I have 2 slides left. We're not limited to only doing one transformation at a time. So let's try a couple where we have more than one thing we need to do. So I want to tell what the transformation would be and graph this. Yeah, we do have to graph it too. So for this first one, what's the plus 2 going to do to my graph? And what's the minus 6 going to do? Okay. I didn't write out, draw this and then draw your final graph. What's my parent function here? Right, we have an absolute value. So we start with the absolute value function. Absolute value of 0 is 0. 1, 1, 2, 2, negative 1, 1, negative 2, 2. Alright, so then we have to move each of those left and down. So our final graph looks like that. Can you tell me the domain of this?
What are the numbers?
Negative infinity to positive infinity. What's the range?
Negative 6 to infinity.
Okay. So some of the questions that you're going to have for homework is they're just going to give you a function and say give the domain and range. Take a second and just draw your transformation, and then you can give your domain and range from it. All right, so B. What's this graph going to do?
Up, or right.
Bless you. Right, 1 and up 4. And what's the parent function?
X cubed.
X cubed. We see that third power, so we're graphing x cubed to start with. So 0 cubed is 0. 1 cubed is 1. Negative 1 cubed is negative 1. If you know what it looks like, that's enough. If you don't, do more points. 2 cubed is 8.
Always refer to the dashes.
Negative 2 cubed is negative 8. There's our starting point. And then we take each one right and up.
I always think my lines and my first line solid.
You always think what?
I always think my first line solid.
Oh, just, I mean, if you do that, you can just label it and say this was the parent function.
I always make it solid and then just erase some big dashes.
Yeah, that works too. So we get this graph. What is the domain and range of this one?
The negative infinity to positive infinity for both.
Mm-hmm. Domain and range both ends keep going forever, so it hits everything. Okay, I'm going to put question up here, and I want you to do this one on your own. I want domain and range of this. So, parent function, square root. Can you do the square root of a negative?
No.
So, square root of 0 is 0, 1, 1, 4, 2. So the parent function looks like this. Did everybody get that part? How are we moving this graph?
Right 3 down 2. Or right
Down
2 down 3.
3.
You know, I just went.
You're just making sure I was paying attention.
You wrote that wrong. Down 3.
See? You weren't paying attention.
Okay, so right
Okay.
and down.
I'm not gonna lie, I didn't really graph it, to be honest.
What's the domain of this? Could you graph it if I asked you to?
1
Yeah.
to infinity. Oh, 2
Two to
to
infinity.
infinity.
2 to infinity, 2 gets a bracket.
I put a negative.
What's
Negative
the
3 to
range?
Negative 3 infinity.
All right, so if I'm asking for domain and range, You may know it, like if it's an x cubed, you may know it's always negative infinity to infinity, but if you don't, draw a graph and help, okay? The assignment is on MathXL. So some of them are just like a multiple choice, some of them are actually graphing. On the MathXL graphing functions, I think you'll figure it out, but you'll have to click to enlarge the graphing tool, and then you can select like the graph that looks like a cube or the graph that looks like a parabola and tell it how to do it.